Good morning, everyone. We are going to start the chapter number 4, that is Advanced Structural Modeling. We have started this chapter in the last session also. We have seen that about classes and objects, then constructors, some basic things from this chapter. So today we are going to see this in some deep manner. Okay, so we are going to start the chapter number 4, Advanced Structural Modeling. From that, we are going to see some advanced classes, advanced relationships, interface, types and roles, packages, and some object diagrams. Okay. So first we will say about classes. So classes are the most important building block of an object-oriented system. Okay. So a class is a description of a set of objects. What is class is? Class is a description of a set of objects that share the same attributes, operations, relationships, and semantics. That is behavior. Okay. A class implements one or more interfaces. Class implements one or more interfaces. For example, in Java language, like class your class name implements interface name. Okay. Then advanced classes. We have seen that what is class is. Now advanced class is like a class is defined using a class keyword. Okay. Where C of class is in small case. C of that class is a keyword. Here class is a keyword. In that C of that class is in small case. Once a class is defined, instances, that means objects of that class can be created, and each instance can have different copy of instance variables. Here instance variables means attributes or fields. Then the data fields described inside the class are the properties and methods of that object. These data fields are created whenever an object of the class is instantiated. There are some method declaration in class that having some parts. There are 4 parts for that method declaration. That method is having name, then data type of the value written by that method, then list of parameters that are we are going to pass for that method, then instructions inside that method. That means we are going to implement that method. Okay. Then we have seen about constructors. What constructors is? Here constructor enables an object to initialize itself when it is created. Whenever we are going to create any constructor, that object is going to initialize when it is created. Okay. They have the same name as the class name. Class name and constructor names are similar. They do not have any return type. They do not have any return type, not even void. Constructor don't have any return type, they don't not even void. Okay, this is because they return the instance of class itself. They return the instance of the class itself. Here you can see the simple class notations in rectangular format, and here you can see class with all necessary details like class name, then visibility attribute equals to visibility attribute type equals to initial value, then constructors, constructor argument list, then visibility operation with return type and some responsibilities. This is this class with all necessary details. Then here you can see for object, the simple object notation, object name colon class, then object name class, then visibility attribute type equals to initial value, then responsibility. This is object with all necessary details. This is simple object notation, and this is with all necessary details like visibility type and their responsibilities for object. Then operations and methods in advanced classes. Here all operations and methods are also properties of the class. Usually it is mentioned in the third compartment of the class. We have seen the declaration of class, that class declaration is having 3 compartments. First one is class name, then attributes and methods. Okay, that Then at the third part, we are going to declare operations or methods at the third compartment. It also describes all argument required for the method. It also having some arguments for that method. It also describes the return data type of that method. Method is having some return data type, that is void. Generally, it is mentioned in class diagram, not in object diagram. We are mentioned that things in class diagram, not in object diagram. We have seen before that slide that notations for object diagram and class diagram. Sometimes you need to mention some static and dynamic methods also. They may have, they may also have access specifiers. We have seen about some access specifiers like packages, private, protected, and public. We have seen that notations for that visibilities. Then advanced classes. What advanced classes includes? A classifier. Classifier which describes or classifies set of instances having some common features. That is classifier. Classifier describes some set of instances having some common features. Features like a feature declares a structural or behavioral characteristics of instances of classifiers. Some structural or behavioral characteristics of that classifiers. There are several classifiers are there. So what classifier is? It is a mechanism that describes structural and behavioral features. Classifier describes structural and behavioral features of that class. Then classifier includes some classes like classes, interfaces, data types, signals, components, nodes, use cases, and subsystems. Here you can see classifiers. Several classifiers are there like class. See the notation for class. For example, shape. Then this is the attribute for that shape class. Then these are some operations or methods for that class. This is the notation for class. Then interface. Here you can see the stereotype interface. Stateful is the name of that interface with some methods with parameters here. Then data type, another classifier. Here you can see the type stereotype. Data type is integer with values, value range. Then signal stereotype. Here you can see off hook. Then component. Here you can see the notation for component. Then node. Here node. Then use case and subsystem. Here you can see the stereotype as a subsystem, that is component service. Here you can see the notation for component and it is a subsystem. By using that stereotype, we can use this as a subsystem. Here these are the classifiers in object oriented system. Then what that classifiers are? The most important kind of classifier in the UML is the class. Class is the most important classifier in UML. Classes are not the only kind of classifier. However, the UML provides a number of other kinds of classifier to help your model. In UML or in object-oriented system, there are several classifiers are there, but the important is class. Okay, so there are several classifiers are there, like we have seen several classifiers like interface, data type, signal, component, node, use case, and subsystem. Here first we will see the interface. What interface is? It is a collection of it is a collection of operations that are used to specify a service of a class or a component. Here you can see that interface is a collection of operations that are we are going to use to specify a service of a class or a component. We can use that interface or we can implement that interface through a class. Then data type, a type whose values have no identity, including primitive built-in types like numbers and strings, as well as some enumeration types such as Boolean. Okay, these are the data types. Then third one is signal, the specification of an asynchronous stimulus communicated between instances. Signal is used for communicating between instances. Then fourth one is component. It is a physical and replaceable part of a system. Component is a physical or and replaceable part of a system that conforms to and provides the realization of a set of interfaces. That is component. Then fifth one is node. It is a physical element that exists at runtime, that exists at runtime, at least and that represents a computational resource, generally having at least some memory and often processing capability. It is a physical node, is a physical element. Then sixth one is use case. It is a description of a set of sequence of actions. Use case is a set of sequence of actions, including variants that a system performs that yields an observable result of value to a particular actor. Use case we have seen in last lectures that what use case is. It is set of sequence of actions. It is a sequence of actions, okay, that includes number of variants, actors, some system properties like this. Then seventh one is subsystem. It is a grouping of elements of which some constitute a specification of the behavior offered by the other contained elements. Here we have seen that what subsystem is. It is a subsystem of that components. That is, it is a grouping of elements. These are some classifiers that are present in UMLs. Yeah, this is the graphically how we are going to denote our notation for that classifiers. Here we have seen that for class, then interface, data type, signal, component, node, use case, and subsystem. Okay. Then next one is visibility. We have seen the visibilities. There are three visibilities or three levels of visibilities here. It is one of the most important details we can specify for a classifier's attributes and operations. That is visibility. Here the visibility of a feature specifies whether it can be used by other classifiers or not. We can specify this that after giving visibility that the other specifiers or other classifiers can use these attributes or some that feature or not. In the UML, we can specify any of the three levels of visibilities. There are three levels of visibilities. That is, first one is public, protected, and private. What public is, that is any outside classifier with visibility to the given classifier can use the feature specified by appending the symbol plus. This is the notations or representation of public visibility using plus sign. That means any outside classifier with this visibility can access the features for that another classifier. Then second one is protected. Protected means any descendant of the classifier can use the feature specified by appending the symbol for that visibility is hash or preprocessor. We can use this protected in case of inheritance. Okay, that is descendant means that is derived class. Then third one is private. Only the classifier itself can use this feature within that class, or we can within that classifier we can access that members of that classifier. For example, like class, we can only access that member of that class within that class. That is, for that private visibility, the symbol is minus sign. Yeah, this is three visibilities, that is public, protected, and private. Here see the example of visibilities. Here toolbar is the class. Here these are the attributes and this is the operations or methods. Here hash current selection colon tool and hash tool count colon integer. These are the types of that attributes. Here you can see hash, that means protected visibility. Then for that methods, plus means public visibility. Then again hash means protected and minus means private. Okay, this is the example for visibilities with the class. Then scope. What is the scope? That is, it is another important detail we can specify for a classifier's attribute and operations is its owner scope. That is owner scope. Who is the owner of that classifier? Okay. The owner scope of a feature specifies whether the features appears in each instance of the classifier. In the UML, we can specify two kinds of owner scope. First one is instance and classifier. What instance is? Here each instance of the classifier holds its own value for the feature. It holds own value. Instance scope means it holds own value. Here you can see the class name frame, then header colon frame header. That is instance scope. Here you can see the instance scope. That means it holds its own features or own values. Then classifier. There is just one value of the feature for all instances of the classifier. Here class scope, that is classifiers, that is unique id colon long. Okay, that means this id is unique for the whole classifier or with only one value for all the instances of that classifier. Then next point is advanced relationships. We have seen the relationships in basic structural modeling. That what relationship is, now we are going to see advanced relationships. What advanced relationship includes, that a relationship is a connection among things. Relationship means it is a collection, or sorry, it is a connection among different things. There are three kinds of relationships in advanced relationships. There are three kinds of relationships. First one is composition, association and aggregation. What association is, objects are aware of one another, that is association, objects are aware of one another. Then aggregation, it protects the integrity, function as a small unit, then control through one object propagation downward. Then composition, each part may also be a member of one aggregate object. These are the three advanced relationships in advanced structural modeling. First, we will see about dependency, that means usage relationships. A dependency is a using relationship, specifying that a change in the specification of one thing may affect another thing that uses it. Okay, for example, class A or class B, both are okay. That there are two classes, class A and class B. Okay, there is a relationship between class A and class B. Dependency using, it is rendered as a dashed line. Okay, directed to the thing that is dependent on. That means suppose class A is dependent on class B. Here you can see the example of car and wheel. Here you can see car is dependent on wheel. Here this is the uses relationship or dependency. Car is dependent on wheel. Okay, that means if is there any changes in this class, it will affect on this. Okay, see the example for dependency relationships. Car is the class and wheel is another class. See the representation of dependency relationship, that is dotted directed arrow with use stereotype. Okay, this is the dependency relationship. Then next one is enumeration relationship. A data type is the description of the value. It may include numbers, strings and enumeration. Data type, data type means whenever we are going to specify any data type for any attributes, that means it is a description of that value. That may be number, strings or enumeration. That enumeration is a finite set of values. It is a finite set of values. It is very useful if some data types having only few types of the values. Here you can see the example, two classes, class exam and class result. Here you can see that uh, how enumeration is rendered like dotted directed arrow. Here you can see the class result is dependent on the class exam. Okay, this class result is dependent on class exam. Okay, this is the enumeration relationship. The next one is generalization, that is inheritance is a relationship. Generalization, what generalization is, a generalization is a relationship between general things, like we can say it's a super class or parent class, and more specific kind of thing like subclass or child class. It is a relationship between a general thing like super class to subclass, okay, or parent class to child class. It is also called as a class hierarchy or inheritance. This relationship manages the complexity of the system by ordering the classes in the form of a tree with increasing level of abstractions. Then specialization. It allows the capture of the specific set of objects that have not been distinguished by the classes already defined. It is an extending technique of a subclass with new characteristics. Here you can see the specialization, representation of generalization and specialization. Here you can see generalization and specialization are two opposite viewpoint of concept of classification. You can see here, this is the generalization and specialization is exactly opposed to generalization. Here you can see the example of superclass and subclass. Here, see the directed plane arrow. This is superclass and subclass. This is the generalization. Okay, see the representation for generalization and specialization. Okay, so there are four standard constraints that can be applied to the generalization relationship. In last sessions, we have seen these four constraints for generalization relationship, that is complete, incomplete, disjoint, and overlapping. Okay. So complete, we will use the complete constraint when we want to show explicitly that we have fully specified a hierarchy in the model. At that time, we can use this constraint, that is complete. Then incomplete, we will use this incomplete to show explicitly that we have not stated the full specification of the hierarchy in the model. Then disjoint and overlapping. These two constraints apply only in the context of multiple inheritance. Whenever we are going to implement any multiple inheritance, that time we can use this constraint, that is disjoint and overlapping. Then next relationship is link and associations. So what is link? Here, the link is the relationship between the two objects, whereas association is the relationship between two classes. Okay, link is the relationship between two objects, and association is the relationship between two classes. So therefore, object is the instance of a class. Okay, object is the instance of a class. Similarly, link is the instance of association. Link is relationship between two objects, whereas association is the relationship between two classes. That means if object is the instance of class, then link is the instance of association. Here association is the communication between the classes. Okay, they can be either unidirectional or bidirectional. We can show this association using navigability arrow. Okay, association may be unidirectional or bidirectional. So every association has an association name, then multiplicity, or we can say cardinality, then qualifiers, aggregations, navigability, that means uni or bidirectional, then visibility like public, protected, private for properties and methods. See cardinality or multiplicity. Multiplicity can be expressed as exactly 1, 0 or 1, many. Here you can see the representation for multiplicity. Many means 0 to many or many. 1 or more means 1 to many. Yeah. Then exact number like 3 to 4 or 6. We can give exact multiplicity to that associations. This is all about multiplicity. Then next one is types of association. We have seen the types of association in basic structural modeling also. Now in advanced structural modeling, we are going to see the types of association. There are many types of associations like qualified association, or association, an array association, association class, recursive association, order association, and navigation. So we will see this one by one. So what is qualified association? Here you can see we are having like given an object at one end of an association to identify an object or set of objects at the other end. Here you can see we are having object at one end of association, that is qualifier, and to identify an object or set of objects at the other end. Here you can see the association between these two classes. Here qualifier, job id colon integer. Okay, type with value. Okay, here this is the qualifier and this is the association, that is qualified association. Okay, for that work desk is work desk having job id for return item. Okay, like if student is the class, then student is having id, then it is lim in college. Okay, that is student. For consider this is the this class name as a student, then student id with integer and college. Okay, so that means here student id is a qualifier and association for that college. Okay, so next association is or association. Okay, we have seen it or association in last sessions also. That means here there are three classes: class A, class B, or class C. It is the case when only one of the several available associations may be instantiated at one time for any single objects. Okay, either class A or class B or class A or class C. Okay, this is or association. Okay, so we will see the remaining part in next session. Okay, so that's it for today's session. Thank you.